Probability simulations. This video contains 3 examples. Firstly, with every breakfast cereal, there is a free coloured toy, and there's 6 coloured toys to collect. How many packs of breakfast cereal would you need to buy to be able to collect all 6 toys? Well, one way of maybe estimating this would be to devise a simulation experiment. Because there are 6 toys, you might maybe use a dice as one way to do this, or a die is a singular bit. So if we could assign each number on a die to a particular colour, what we could then do is roll the dice and keep rolling it until all 6 numbers or all 6 colours have come up. And we could repeat this several times then to see on average how long would it take to get all 6 numbers. This could be speeded up maybe if you used maybe a computer generator. So here on random.org, for instance, you can generate maybe 60 dice going at once. And when we do this, we would see, when I did it first time, I see it was 11 times before it repeated itself. And if I did it more times, you could see on average how long would it take. That's maybe using technology is a good idea here. Example 2. So families have 5 children, and we want to investigate the probability that boys would outnumber girls. Well, a coin might be good for this simulation. You could let a head equal a girl and a tail equal a boy, and you could toss a coin 5 times and record the outcome. Then you repeat this several times to see on average what happens. Would it be more boys than girls? You could use a piece of computer software, or online here, random.org would allow you to toss 5 coins all at once. That would speed up the process. You could record the results. The expected probability would be 1/2 for a boy, and the expected value out of 5 children would be 2.5 of them would be boys and 2.5 would be girls. In example 3, we're told 4 people are selected at random from a large crowd. We're to work out the probability that 2 or more of them have birthdays in the same month. Now, the easier way to do this question is to think first about the opposite of that. What's the probability that they would be all born on different months? If we subtract that from 1, we have the answer we're looking for. So how would we work out the probability they're all in different months? Well, if we think about the 4 of them one at a time, the first person will be born in a month. So that's certain, it's 1. Now there's 11 out of 12 chance the next person is in a different month. 10 out of 12 chance that the next person is in a month different than the other 2. And there's 9 out of 12 chance that the last person is born in a month that's different than the other 3. So if we take out the calculator and work out this. So we see the mathematical probability that 2 or more of them share a month that they're born in is 41 out of 96. In the second part, we're asked now to work out or devise a simulation that could determine the probability of this happening. So one thing you could use that you'd have at your disposal is your calculator. You could use the random integer generator on your calculator. What we could do is we could set numbers 1 to 12. That's what we might pick, and let each number stand for a month of the year. So what we do is we just do 4 at a time. So randomly generate numbers 1 to 12, 4 at a time, and see how often does it happen that out of the 4 that we have at least 2 sharing. So we'd expect it maybe to be roughly around 4 out of 10 times if we do it enough times that this would happen. So I'll show you what this looks like. So if you take out your the Casio calculator, what you would do is press alpha and the rand int button where the decimal point is. So we set the parameters as 1, and 12, and then just keep pressing equals. And every time you press equals, it generates a new number. So if you do this in groups of 4, let's see when it will happen that they would repeat.